All right. Talk me through this warm-up. Are angles ABC and XYZ congruent? Yes. Why? That's absolutely correct. Fantastic explanation. XYZ and XYW are a linear pair, so they have to add up to 180. We know that XYW is 140 degrees, so XYZ has to be 40, which is the same size as ABC. Remember, to be congruent means their sizes are equal. All right, what about segments FG and DE? Are they congruent? No. Why not? Absolutely. These two are not equal. Because they're not equal, that means they cannot be congruent. So what about segments OR and OS? Yes, because they are both 2 inches. 2 inches is equal to 2 inches. Angle 2 and angle 4? Yes, because they are vertical angles. We don't know how big either one of them is, but they have to be the same because vertical angles are always congruent. Angle ROQ and ROP. Yes. Let's look at it carefully. We have lines RS and PQ crossing. And right up here, it tells us that angle SOP is how big? 90 degrees. So its vertical angle would have to be 90 degrees. ROQ is the vertical angle to POS. ROP is a linear pair to ROQ. So together they have to equal 180. Well, one of them is 90, so the other would have to be 90 so that they add up to 180. So those are both right angles. Nice work on the warm-up. I especially loved the explanations. We're going to be in both your notes and your book today. We're going to start off in your notes. We're going to be at the top of the second page. We finished off the first piece of paper yesterday, so we're on the second page now. We're going to learn how to use triangle congruent statements, to solve problems. So yesterday, we had triangles and polygons that were marked up with congruence, and we practiced writing down our corresponding angles and then writing down our corresponding sides and using that to write a congruent statement. Today we're going to kind of be going the other way. We're going to start with a congruent statement. We're going to use that information to mark up our triangles. And then after we've marked up which sides are congruent, which angles are congruent, we're going to be able to answer the questions or to set up equations that will answer our questions. So on number 3 in your notes, we have that triangle JKL is congruent to triangle QRS. Each of these letters, J, K, and L, represent an angle in one of our triangles. And the order that those letters are in, the order that those angles are in, is really, really important because it tells me what? Which ones are congruent. So angle J in the picture, which is right up here at the tippy top, is congruent to what? Angle Q, right over here. How big is angle J? 24 degrees right here. So since J and Q are congruent, that means angle Q is how big? 24 degrees. So I can add that to my other picture, 24 degrees for the measure of angle Q. What other angles do I know are congruent because of my congruent statement? K and R, second letter, second letter. So here's my angle K. And over here is my angle R. What other angles are congruent? S and L. Angle L is down here at the bottom. Quick question. Why would this be wrong? Right here. Q has 3 lines, J has 3 arc marks on it. I've already used that. There's nothing telling me that J and L are the same size. So I need to not have the same number of arc marks on them unless I know for a fact that they're the same size. You get to decide how many arc marks you're going to use on these angles. However, if it has the same number of arc marks, you're saying that you know for a fact that they are congruent. So angle L and angle S, I wasn't able to fit it right down here in the corner because we have 34 degrees there, which means what about triangle JKL? L is congruent to S. You guys told me that because of the congruence statement. And so that means what? What should I be able to add to my picture now? What new information can I add? L is how big? 34 degrees. The measurement of angle L is equal to the measurement of angle S. So the measurement of angle L would have to be 34 degrees. When I mark up my triangles with the congruences, any bit of information that I can take from one and put on the other, I do. Anytime things are congruent, that means that they have equal measurements. All right, we got all of our angles marked. Triangle congruent statements don't just tell me about my angles, though. They also tell me about my sides. I'm going to use this triangle congruent statement here. In the first triangle, the first 2 letters are JK. So I'm going to go find side JK on my triangle. That's this one right over here on the left. JK, according to the congruent statement, is congruent to what other segment? QR, first 2 letters right here. So I'm going to come over to the other triangle, and I'm going to put the same number of congruence marks on that one that I put on JK. How big is side JK? 12.9. So how big is QR? 12.9. JK is congruent to QR. So the measurement of JK is equal to the measurement of QR. So that means that QR is 12.9. What other sides do I know are congruent because of this congruent statement? We did first 2 letters KJ or JK and first 2 letters QR. KL has to be congruent to what? RS. KL right here is congruent to RS right here. And finally, we can also say that what other 2 segments would have to be congruent? JL, and I'm sorry, I didn't hear the other piece. QS, first letter and third letter, JL, congruent to the side that is first letter and third letter, QS. So JL is congruent to QS. How big is JL? 19.3. So that means that QS is also 19.3. Segment JL is congruent to segment QS. So the length of JL is equal to the length of QS. So 19.3 is equal to the length of QS. That's where we're getting this from. So far, so good? Yes. Yep. What's the first thing they ask me to find in this problem? Part A, what do they want me to find? The measurement of angle JKL. So JKL. down to K and over to L. So they are asking me to find this angle right here. We know that angle K is congruent to what? Angle R. Do we have an actual number of degrees for angle R? No. Then I'm not going to be able to use that to help me figure out JKL. What else did we learn? We've been practicing this week. What else have we learned to be able to find angles inside of triangles? They add up to 180. That's our triangle sum theorem. All the angles inside of a triangle add up to 180 degrees. So the measurement of angle JKL plus, how big are the other angles inside of that triangle? (24 degrees). That's angle J up at the top. And 34 degrees. That's angle L down at the bottom. And why did we know that angle L was 34 degrees again? Because that wasn't printed on my triangle. Because it's congruent to angle S, and angle S is 34 degrees. So I have that angle JKL plus 24 degrees plus 34 degrees equals 180. Let's combine our like terms together, 24 and 34. What do I get when I combine those together? 58 degrees. So the measurement of angle JKL plus 58 degrees equals 180. Kind of run out of room here, so I'm going to bring the rest of my work around over here. I need to subtract 58 degrees from both sides. And that's going to give me the size, absolutely, of angle JKL. The measurement of angle JKL is 122 degrees. So I'm going to add that to my picture since I now know that piece of information. This right here is 122 degrees. And then we get to part 2. Part 2 says, or sorry, not part 2, part B says find the values of X and Y. Where is X in this picture? 5x minus 4y. Which segment is that? Segment RS. All right, so from here over to here. 5x minus 4y. What segment is congruent to RS? KL. So segment RS is congruent to segment KL. That means the length of segment RS is equal to the length of segment KL. RS is 5x minus 4y. How big is KL? It is 9.1 right here. Do I have enough information right now to be able to solve for X and to have just a number as my final answer? No. What do I still need? What'd you say? I need to have what if I'm going to get X all by itself? Well, that's what I'm going to find, but I can't find what it equals to because there's a problem with my equation. I didn't set it up wrong. There's two variables. They're different variables. I can't combine them together. So until I know the size of one of them, I can't find the other one. So I can't find X right now. Is there something that I could do to find Y? Is there another Y somewhere in the picture? Where is there another Y? QR. Are you sure it's the segment? Do you guys see that arrow that's pointing down here? This 2y plus 2 is pointing to angle R. And we know from our triangle congruent statement that angle R is congruent to what other angle? Angle K. Do we know how big angle K is? 122, that's what we just found up above. So I can do 2y plus 2, that's the measurement of angle R, is equal to 122 degrees. That's the measurement of angle K. Can I solve this to find out what y is? Yeah. What would be my first step? Minus 2 from both sides. What is 122 minus 2? 120. So 2y equals 120. And what after that? Divide both sides by 2. So y is how big? Y is 60. Not necessarily 60 degrees because I don't have an angle that's y, but it's 60. If you guys accidentally stick the degree symbol on here, I'm not counting off for that. But I do want to keep reminding you guys that unless it is a whole angle, we don't put degrees on it. So y is 60. Now I can come back over to the other equation that I was trying to solve, and I can substitute 60 in the place of y. So now I have 5x minus 4 times 60 equals 9.1. Is that an equation that I can solve now? Yes. What is 4 times 60? 240. So 5x minus 240 equals 9.1. Walk me through the next couple steps. Negative 4 times 60, I'm still going to get negative 240. So it's still going to be a minus there, yes. But you could look at it as negative 4 times 60. Yep. What are my next couple steps to solve this? Yes. Add 240 to both sides. So I have 5x equals 249.1. And last thing I need to do to finish isolating x. Divide by 5. $249.1 divided by 5 gives me what? I have to use a calculator for this one because I can't do it in my head. What'd you say? 49.82. Double check that you didn't accidentally put it in the calculator backwards. Okay. 49.82. So far, so good? All right. Let's go look at problem number 4. What's the first thing that problem number 4 says? Draw a picture. What are we going to be drawing a picture of? Triangles. How do you know? I absolutely agree. Yep, it has a triangle congruent statement right here. Do I just draw one triangle? No, I need to draw 2 triangles because we have 2 triangles that are congruent to each other. So on your page, I want you to draw 2 triangles. They can look like whatever you want. My triangles are going to look like this. Thank you. So your triangles don't have to look like mine, but you do need 2 triangles on there. After you get your triangles drawn, what should you do? Label them. One of my triangles should be called what? JKL. All right, so J, I get to pick whatever corners I want to put my letters on. J, K, and L. And then the other triangle I need to call what? M and P. So M, N, and P. We know these triangles are congruent. So before I do anything else with the information they've given me, I want to mark up my triangles with their congruences. Which angles are congruent according to my congruence statement? Which angles are congruent? J and M, first letter. So angle J should be congruent to angle M. You absolutely do need to be marking up your pictures. What else do we know is congruent? K, second letter, with N, second letter. So K right here, and N right here. I'm sorry, what'd you say? You need to mark the angles that are congruent with the same number of congruence marks. So like K, I had just one arc mark, so I would want just one arc mark on N. But if you used one mark on J, you would use one mark on M, and then you would have to do something different for K and N. If they have the same number of arc marks, you're saying that you know for a fact that they are the same size. Yes? If the letters are in different places, it's telling you something different. The order of the letters is telling you which angles are congruent. So the first letter of the first triangle statement is congruent to the first letter of the second triangle statement. The middle letter is congruent to the middle letter. The last letter is congruent to the last letter. If you had it in a different order, it would have things congruent to different pieces. Yes, sir. When she gets back. What other angles do we know are congruent? L and P. So angle L and angle P. I gave this one 3 arc marks because I already used 1 and 2. And I don't know that angle L is congruent to any of the other angles except for P. Sylvia. All right, so we've got all of our angles marked up. Using that triangle congruence statement, can you tell me which sides would have to be congruent? JK has to be congruent to what? MN. First two letters, first two letters. What other sides have to be congruent? JL, first and third, to MP, first and third. Sorry, that got a little messy for me. And finally what? Sorry, I couldn't hear. PN is congruent to LK. LK congruent to PN. So now we have our triangles all marked up. One thing I definitely want to warn you guys about is to not rely on the way the triangle looks to do your triangle congruence statements. When you are doing triangle congruence, when you are marking them up, you need to go off of the congruence statement, not the way the picture looks. What other information did they give us about these triangles? Did they give us any angle sizes? What angles did they give us? They gave us angle L. How big is angle L? 73 degrees. What else do we know? M. How big is M? 24 degrees. What else do we know? Angle K is 2y plus 8. What else? Angle P is 5W minus 11, so down here. Is there any other information that we know? JK equals 24, and that's a side. That's right here. That's right next to my triangle congruence statement. What else do I know? LJ is 15. This gives me a great opportunity to stop for just a second and point out what I was saying. Which one's bigger, 15 or 24? 24 is bigger, but on my triangle, which side appears to be bigger? Yeah, JL appears to be bigger with the way I drew my picture. My picture's not reliable for sizes. My picture is not reliable for congruence. I have to go off the information they give me.
Change anything on the text has to be on a separate sheet of paper. You can get a sheet of paper from the middle shelf right there, and you're welcome to sit at any of the open desks.
All right, anything else I know? Yep, corrections on there. There's one more thing that they told me. PM, which is a side, has a length of 6x minus 4. So I drew my triangles, I marked up their congruences, I added all the information that they gave me. Now they want me to find what? X, Y, and W. Where is X in this picture? Where is X? Between M and P. Right here. It's the last thing that we wrote down. Well, segment MP or PM, doesn't matter which order you put that in when you're writing the segment name, is congruent to what? JL. Because the segments are congruent, that means their lengths are equal. We said that segment PM was how big? 6x minus 4. How big is segment LJ? 15. Oops. Can I solve this with the way it's been written now? Yes. We're going to add 4 to both sides. So I would get 6x equals what? 19. Then I need to divide both sides by 6. When you do 19 divided by 6 in your calculator, do you get a whole number back? No. Since you're going to get a decimal, my next question is, can you write down all of those decimal places, or does it run to the end of the calculator screen? Can you write down all of the decimal places, or does it run to the end of the calculator screen? You can't write them all down. There's way too many. Because it runs off the calculator screen, we're going to leave our final answer in fraction form. We are not going to write down a decimal and round it. Leave it in its fraction form. All right, we found X. We're still supposed to find Y. Where's Y? Angle K, 2y plus 8 degrees. Angle K is congruent to what other angle? Angle N. That means the measurement of angle K is equal to the measurement of angle N. Angle K is 2y plus 8. How big is angle N? We don't know. Then I'm stuck. I'm not going to be able to find y by doing this. What other way do we have of finding angles other than using our congruence? What did we learn earlier this week? Triangle sum theorem. Let's try to use our triangle sum theorem then. Bless you. All right, in my triangle sum theorem, the measurement of angle K plus the measurement of angle J plus the measurement of angle L equals 180 degrees. Angle K, we already said, is 2y plus 8. How big is angle J? 24. How do you know? It's not written up there. Angle J is congruent to angle M. So the measurement of angle J is equal to the measurement of angle M, which means angle J is 24 degrees. So I can take that and add it to my picture and substitute that in my equation, 24 degrees. So 2y plus 8 plus 24 degrees plus, how big is angle L? 78 degrees is equal to 180 degrees. 73. Oh, sorry, I couldn't read my own handwriting this far away. Thank you. 73 degrees. Should have looked closer. We need to solve this, which means I need to combine my like terms. What are my like terms? 8, 24, and 73. What do I get when I combine all of those together? 100 and, I'm sorry, how much? 109. 24, 73. That would be 97. 97. And 8. I wasn't getting 109. I was getting something different. 105 is what I got when I added those. So 2y plus 105 equals 180. Subtract 105 from both sides. What is 180 minus 105? 75. So 2y equals 75. Divide both sides by 2. Is this going to come out as a whole number? No. Can you write down all the decimals that it shows you? Yes. What is 75 divided by 2? 37.5. So we can write this one down in its decimal form. Or if you want to keep it in its fraction form, you may absolutely do so. You could leave it as 75 over 2. I would accept either of those as a correct final answer. The only time I care about what form your answer is in is if that fraction, when you put it in your calculator, ends up with a decimal that runs off the screen. Then I want you to leave it in its fraction form. But if it's not a decimal that runs off the screen, you can write it in its decimal form there. All right, we found x, we found y. What do we still need to find? W. Where's W in the picture? Angle P. Angle P is congruent to what other angle? Angle L. So that means the measurement of angle P is equal to the measurement of angle L. Angle P is 5W minus 11. How big is angle L? 73. So what do I still need to do then to solve for W? We're going to add 11 to both sides. So 5W equals 84. And then what? Divide both sides by 5. Does this come out to be a whole number? No. Is it a decimal where I can write down all of the decimal points? Yes. What is 84 divided by 5? You said what? 16.8. Or if you want to leave that in its fraction form, you can have 84 over 5. All right, we're going to switch into your book now. Page 298 in your book. Let me get you some graphs that you can do this on. Okay. Page 298, that's the page that we were on yesterday in your book. This is right underneath the problem that we did in your book yesterday. We have a triangle congruence statement. Which triangles are congruent? What are the triangles that are congruent? RSV and TVS. This is the first time when we've been talking about triangle congruence that we have two triangles that are touching each other and they're congruent. So as I'm going through and marking up my angles and my sides that are congruent, I need to know for sure which triangle I'm looking at. Because if you look at S, there's two angles at S. There's one on the left and one on the right. Same thing for V. There's an angle on the left and an angle on the right. And so I've got to be careful to stay within the triangle that I'm looking at. So I'm going to put some colors around my triangles to keep me grounded. Triangle RSV, I'm going to outline in red. And triangle TVS, I'm going to outline in blue. That way I can talk about the blue triangle and the red triangle, and I can try to keep myself straight. So RSV is my red triangle. TVS is my blue triangle. Which angles are congruent to each other? R and T, so angle R, way over here on the left, is congruent to angle T, way over here on the right. What other angles are congruent? S in my red triangle is congruent to what in my blue triangle? V. So those would both be right angles. And finally, which other ones are congruent? Angle V in the red triangle and angle S in the blue triangle. How big is angle S that's in the blue triangle? How big? 90 is angle V in the blue triangle. How big is angle S that's in the blue triangle? 78. Here's 78 degrees right here. It's got an angle pointing to this angle. So that means this angle right here is also 78 degrees. What about my sides? Which sides are congruent? RS, first two letters, is congruent to TV, first two letters. So RS is congruent to TV. Which other sides would be congruent? SV and VS. Well, SV is this side right here, and so is VS. So that part of the congruent statement is telling me that this side is congruent to itself. What does congruent mean again? Same size. Does it make sense that if I'm talking about only one line segment that it would be congruent to itself? It's the same size as itself. Yeah. All right, there's one more. What else is congruent? RV, this side here, first and third letter, is congruent to TS. This one right over here, first and third letter. We are supposed to find X and Y. I don't like the way your book finds X. So I'm going to scratch all this out. You can do yours in the margin. Where is X in the picture? Yep, angle T right here. They had to draw it outside of it because they couldn't fit that little X in there. But they have that arrow pointing there. And angle T is congruent to what? Angle R. Do we know how big angle R is? Then I'm kind of stuck there. If I can't use my congruence to solve this, what else could I do? Triangle sum theorem, yes. Triangle sum theorem tells me what? That all the angles inside of triangle add up to 180 degrees. So the measurement of angle T plus, what are the other angles in this blue triangle where angle T is? How big are the other angles? $90 and 78. So angle T plus 90 plus 78 degrees is equal to 180. And the measurement of angle T, that's where X is. So X degrees plus 90 degrees plus 78 degrees equals 180. Are there any like terms that I should combine together? 90 and 78 get combined together. What is 90 plus 78? 168. So X degrees plus 168 degrees equals 180 degrees. If I subtract 168 degrees from both sides, I'm going to find out how big angle X is. Or how big angle T is, sorry. I'm going to find out the size of X. What is 180 minus 168? 12. So X is 12. Last thing we need to do for today is to find Y. Where is Y in the picture? 2Y minus 1, which is on which side? Left side, RS. Segment RS is congruent to which segment on the other triangle? VT. We know that RS is 2x minus 1. How big is TV? 24. It's not degrees on this one because it's a side. Only our angles get degrees, but we have 24 right here. What do I need to do to this yet to find Y? Add 1 to both sides. So let's go ahead and do that. What is 24 plus 1? 25. So 2y equals 25. And then divide both sides by 2. Is 25 divided by 2 going to be a whole number? No. Can I write down all the decimal places? What is 25 divided by 2? 12.5. Or if you prefer, you can leave that in its fraction form. 25 over 2. When's the only time I care about which form you leave your answer in? When you can't write down all the decimals because it runs off your screen. All right. That's where we're going to stop for today. You guys do have homework due tomorrow. There was a worksheet that you should have picked up yesterday. If you don't have that, or if you've lost yours, or you weren't here yesterday, You can get that from the bottom of this red set of papers. If you misplace it and you get all the way home, it is also problems straight from your book. There are 8 total problems on your homework assignment that's due for tomorrow. I'm going to go ahead and pass back the tests that you guys took last week because those are all graded. They will be going into Skyward shortly, but they are not in Skyward yet.